Hey, hello everyone. I want to give a quick introduction of how to create a Kubernetes cluster. So basically, we'll start with basic fundamental concept of Kubernetes clusters, and then how we can deploy an application in Kubernetes cluster and basically do a full automation. So let's get started. So the first thing is let's make it very easy, right? Let's start thinking of why we need a Kubernetes cluster. So Kubernetes cluster is basically a container orchestration tool. It basically helps us to achieve three things, right? It helps us to scale. It addresses the scalability concern, which standalone container like Docker doesn't much handle. And second is basically um, backup and restore. Say let's say you need to restore. So let's go through key concept, right? Why do we need it? Why? So the why part is, I would say, number one is, we need a scalability. Number two is basically backup, restore. We need to scalability, backup and restore. And then third is availability, high availability. And that little bit of related to scalability, right? I mean, if you have a highly scalable system, then it will also ensure an availability. So these are the three whys we need to remember. Why do we need K8 cluster? So let's that's the number one block. Now, once we know K8 cluster, so first we what we do in this Kubernetes cluster, we deploy containers, right? We deploy containers. So let's understand few basic concept of Kubernetes actually. So the number one concept, so let's say concepts is called pod. So this is basically an abstractions of a container. Okay. So pod is the atomic unit in a Kubernetes cluster where um, you when you deploy an application. So first, what are the steps? You have an application, you containerize that application, and then you basically deploy that application container into Kubernetes cluster. What Kubernetes cluster does is it's basically create pods for those application into its different worker nodes. And we will get into those details of Kubernetes architecture, but the pod is basically the application, and it is pod is ephemeral. That means, if a when you deploy an application in a Kubernetes cluster, based on the configuration you have in your deployment, it creates those many pods. And if let's say you have configured three pods to be created, it will create three pods, and those they are going to get load balanced through services. But one pod is, let's say, not responding. Let's say it's a three node cluster, one node is highly used for resources for compute and storage, then it's not responding, then basically Kubernetes has something called control manager which detects that, and then it tells its scheduler to recreate that pod, and scheduler then basically finds out the best node which has the least amount of which has the more availability of the other resources like CPU, storage, and compute, and memory. Then so it creates there. So that's how, that's basically the concept of pod. It's a basic unit. And then after pod, we have so the pod is there. Now pod has a K8 cluster. It has a IP address assigned to it, and it's ephemeral. That means it's ephemeral, right? Um, then service. So because pod, if pod gets killed, the service will IP will change. So the pod generally accessed from the outside. Pod doesn't get access from the outside directly. It has another abstraction layer called service, and service lifecycle is different from pod lifecycle. It keeps it has a static IP address which does not change if a pod killed and recreated by K8 cluster. And now there could be two types of service, right? Internal service, external service. Okay, then now service is like an IP address, right? So service is, as I said, it's a static IP. Uh, However, so we use, so then there is a concept of ingress. This gives this assigns a DNS name to a pod. This allow basically this allow pod access from outside via DNS domain name, user-friendly domain name. Okay, so and then there is a concept called deployment. So basically, we don't deploy application directly. We or container. We basically have an application, containerize that. Let's say we Dockerize that using Docker file, or containerize that, and then we basically create something called deployment. And deployment, we mentioned the replica, how many replica application will be there. So deployment is basically actual. We mostly deal with when we have to deploy on a container. We actually have we actually use the deployment for that. So here we define number of pods needs to be created for that application. Okay. Okay. Now we got the deployment, and we talk about services, right? Now this uh, for that applicant, this is used for stateless application. Okay. Now next concept of volume. Now if a application has state like database, we need to use volume attached to the so that if pod gets scaled, the volume reference switch to another newly created pod. This is a complex operation Then we have stateful set. For stateful application, stateful set is used to deploy a container in K8 instead of deployment. So let me just okay. And then there is something called we need to understand zero downtime deployment via termination grace period, right? Basically, in Kubernetes has a great great concept of zero downtime deployment. So let's say you have a container, you have an application which is version 1, and now you wanted to deploy another application, the v2 of the same application, and let's say there are 3 pods are running or 4 pods are running. So Kubernetes actually support kind of what I should say is I think it's called blue green deployment. Pattern. Let's search it. Blue green deployment K8. Search, you will see in blueprint deployment are a form of a progressive delivery where a new version of the application is deployed while the old version still exists. The two versions coexist for a brief period of time while other traffic routed. Exactly, and that's what exactly happened in Kubernetes cluster. It uses the blue-green deployment methodology and it uses a termination grace period. So when you deploy a new version, old version doesn't get wiped off. New version still exists with old version, and traffics are slowly, switch from the old to new, and that's called termination grace period. So so basically, once it's deployed, the all new traffic are switched to the new version, and the old traffic in some time still allowed. That's what termination grace period. They are not accepting new requests, but the old requests are still being fulfilled, and that's the termination grace period. So that's what ensures a zero downtime deployment in Kubernetes cluster, and that's a very important concept. So these are basically fundamental concept of Kubernetes cluster. Now let's understand the architecture, right? What exactly Kubernetes clusters are and how the architecture is. So as I said, there is a basically a master node and a worker node. So master nodes are basically control plane, like in cloud concept, right? It is a control plane. So it's a master, let's say 1, 2, 3, and it can scale. So this scales differently. So master node scales differently. So let's say call it master. Okay. So let's do 2 master node and 4 worker node. Okay. I'll bring it back here. And let's say this. Okay. So name is master node 1. Let's do this small, middle, master node 2. Okay, so we can keep adding, right? We can keep adding this, so it can scale independently. Scales independent of worker node. Okay, and then you have worker node. This is the heart and soul where the pod lives or the container lives, right? Pod lives here. When you deploy an application, that application actually sits here in the form of a container, and the master node is just control the manages and the whole orchestration, does the orchestration and all this management happens. So fourth, and now let's see what happens in all these things. Okay, so as we said, okay, let's see in the master nodes what we have basically. So here, the key component, the number one thing we have API server. And the API servers are basically, you can think, it can have a UI and it can have a REST call, or it can be a kubectl, which is basically helps us. So number one. Number two is basically you have a scheduler, which actually schedules the pod, creates a pod, and also, and then number three, you have controller manager, which basically checks if pods is healthy or not. If it is not healthy, let scheduler know if actually it needs to be recreated. And then fourth one is etcd. It's a key value database in Kubernetes. Every master node has, and basically that's like the memory of the brain of the Kubernetes. It stores all the metadata, all type of configuration, which nodes has what, all the metadata of the master instance stays here. So, so the same thing goes to the next one, right? So it's same. Now what goes inside the worker node? So worker node has, the number one thing is worker node needs is basically the, mm, 1 second, let me, so it needs a container, right? Container runtime, like Docker. And it can support other container runtime like Rocket, and I think like OpenShift has a different container runtime. They all use Docker files, but they support multiple container runtimes. And second, it uses something called kubelet. The kubelet is basically an interface between container runtime and the node or the VM, and it also interfaces with master node. It receives the request to, uh, let's say recreate a container. All these things. So kubelet is the interface. And then number three is basically it has something called kubeproxy, which basically works like a load balancer or service among the pods in that, and also it's very intelligent. Let's say a pod is so a pod is trying to communicate with another pod, and that time it intelligently checks, if I need if the request should be routed a pod within the same node or a different node. Of course, if it is same node, then it's not a network call, and it can be faster in terms of network latency side, right? So those kind of things does by. So ultimately, the pod lives here, right? The pod lives here. So if I say, let's say, I'll copy paste the same thing everywhere. So Q proxy, okay, and then you will be having basically the pod here, right? So the pods will live here, the container within the container runtime. I'm not showing it here. So apart from this concept, I forgot to say two more important thing here, which is basically called config map. So all configuration like an application need in K8 can be retrieved from config map. And another is basically secret map. So similar to config map, if it's secret, uh, app can contain, or pod basically can retrieve from secret map. However, it stores the secret in base 64 encoded format, which is not really secure. So we should use something like native cloud vault, or like HashiCorp vault, to retrieve the secrets for the application. Okay, so let me take it a little up. I'm just making it a little small. Okay, so that's pretty much all the basic concept of K8 101. Now once we have all the part is created, now there is a separate video we will create where we will show, and we'll demo it also very soon. Hope this is helpful. Thank you.